Oh, I don't think I have one for Mackenzie. I'm still short one. Unless Mackenzie has one already. I don't know. This is notes for 4-1. I think Reese has these notes, but Mackenzie maybe doesn't. Okay, so the two of you girls, we're starting 4-1. We will get probably halfway done with this before quitting for the day. But this is probability. It should go a little bit faster. There's 5 sections to this chapter. Yeah, all of the things. Probability section. Okay, so here we go. Part 1, they do give us a little bit of vocab like they do every chapter or whatever. We have to define some vocab stuff. So let's bump down here and then we'll go back to example 1. Let's talk about event, simple event, and sample space. What's an event in probability?
In the event that this happens.
Yeah. Like an event is like one trial of something, right? One trial, like one roll of a dice, one game, maybe, and you're talking about the probability of the outcome of the game, right? So one trial or one thing happening, right? A simple event has like 2 different outcomes, right? Like a kind of a yes-no, right? Simple event, 2 possible outcomes. Okay. Yeah, we'll just go with that. I don't want to elaborate too much more. 2 possible outcomes, like a yes, no, like win, lose, boy, girl, probability, a flip of a coin, that type of thing. Simple event, okay? Sample space. Let's talk about sample space. Sample space is the list of possible outcomes. So if I am rolling a dice, let's say 1 die. 1 die? 1 dice? 1 die. I think that's how it's said. The sample space for 1 die? No, let's go 1. Not 1 die, 1 coin. I'm going to change that, sorry. 1 coin. Okay, 1 coin is heads or tails. Okay? All right, now if we go on to not a simple event, but like a compound event, okay? Like let's say I have 2 coins and I want to list the possible options or the possible outcomes that I could get with 2 coins. I could get a what?
Heads, tails.
I could get a heads. I could get a heads, tails.
Tails.
Tails, heads, or tails. Yep. Those are the possible outcomes. This is a compound event. Compound. Okay. Sample space is a list of possible outcomes. Okay. Whatever. All right. So compound event versus simple event. Whatever. Okay. Good. All right. Let's go up to the top one. Researchers have made this claim. They claim we have developed a gender selection method that greatly increases the likelihood of having a baby girl. Okay, and when they're testing this hypothesis, the hypothesis used when testing the preceding claim, the method of gender selection has either no effect or it has an effect, right? Yes or no. It either has an effect or it doesn't have an effect. So the couple using this method, about 50% of the births result in girls. Okay, they want to see, is that percentage elevated beyond 50%? If it is, it might be doing something, right? Okay. But later on in stats, we have to decide, okay, like how much does it have to increase before we decide, like, yes, it's doing something, right? Like if our girl to boy ratio ends up being 51% versus 49%, is that enough of a split for you to say, oh, yeah, that's definitely doing something?
Nope.
What does the split have to be? You think 75-25? Would have to be the split?
At least.
What about 74-20 or 76-24 or 74-26?
Pushing it.
Pushing it, right? I don't know. Here we go. So different gender selection methods tested with 100 births. Here we had test result A, and this ended up resulting in 75 girls and 25 boys. And this one ended up resulting in 55 girls and 45 boys. Okay? Now, we don't know. Somebody's spamming me right now. We don't know how to calculate this yet. In Chapter 5, we will figure out there's something called the binomial probability. There's a formula for it of figuring out what the chances are of getting a 75-25 split. We don't know how to calculate that yet, but they gave it to us, and they said the chance of that split happening, right? Let's talk about the different splits that you could have. Girls versus boys, right? I could have 100 girls and 0 boys. I could have 99 and 1. I could have 98 and 2, right? How long is this list?
2, 1, 2, 0, and 100.
100. It's 100 long, right? Because like 0 and 100 would be down here, right? Okay, they're talking about a 75 versus 25 split, and the chances of that happening, we will figure out how to calculate this in chapter 5. The chances of that happening is 0.000003, which if you write it as a decimal, that's 6 zeros, would be 0.1234 zeros and a 3%, right? That is a very, very, very small percentage of that happening, right? The chances of that happening is that percent. Got it? Now, it is considered to be like a rare event, rare or significant, if it's less than 5% chance of happening. Okay? So, if I gave them this medication or whatever it is, and they got a 75-25 split, knowing that it has a 0.00003% chance of happening, is that enough for me to say that medication is doing something? Because the chances of it happening on its own would be 0.00003%, right? Does that make sense? Okay, so it is a rare event for this to happen just naturally occurring. It is very rare for that to happen, which means that the fact that it did happen is like something is causing that to happen. Versus over here, we have 55-45 split, and the chances of that happening is 18.4% or 0.184. 18.4% chance of that split happening. 55-45, that's not that big of a deal, right? Like, that could happen. Okay, 18.4% chance. That's the chances of that thing occurring without any intervention happening. 18.4%. That is greater than 5%, so it's not really rare. Not rare for this to happen, right? Which means that medication's probably not doing anything, because the chances of that happening just randomly without the medication, that could easily happen, right? Okay, so cannot conclude gender selected method is effective, versus over here the gender selection method does appear to be effective, because the chance of that happening is very rare. The chance of this happening is not very rare. Does that make sense? What's the cutoff? 5%. If it's less than 5%, it's considered rare. If it's more than 5%, it's like, whatever. That could happen naturally, right? Okay, my drug did not do anything. Got it?
Yep.
Okay. All right, let's talk about, example 2. Okay. All right, single birth. If I'm talking about one birth happening, one baby being born, I could have a boy or a girl, and that's a sample space, and I know it's 2024, but we're just going to assume that it's boy-girl, okay? All right, just for simplicity's sake. All right, number 2. All right, this is actually 3 births. 3 births happening. Okay, we could do 2 births if we wanted to, but 3 births happening, okay? Boys versus girls. Okay, I could have 3 boys and 0 girls. I could have 2 boys and 1 girl. I could have 1 boy and 2 girls. I could have 0 boys and 3 girls, right? And this is the list of possible events that I could have. How many are there? Combinations. 8. Do you know why there is 8? I have 3 children. I don't have 3 children, but I had 3 children at one point, right? And how many options could that first child be? 2. And options for the second child is 2. And options for the third child is 2. And 2 times 2 times 2 is 8. 8 different combinations. So if you have 4 children, which I do, right, would be 2 times 2 times 2 times 2, which is 16 different combinations, right? Okay, does that make sense? My combination for my children went girl, boy, girl, boy, girl, right? That is just 1 out of the 16 different combinations that I could have had, right? Okay, that's one of the combinations. Make sense? Okay, so it's just listing out things. All right, with 1 birth, I'm in this little bullet point right here. The result of 1 girl is a simple event, and the result of 1 boy is another simple event. They are individual simple events because they cannot be broken down any further. With 3 births, this is a compound event. I have like a bunch of different combinations. There are 8 combinations, 8 combos with 3 births. When rolling a single dice, the outcome is, I shouldn't have said up here that a simple event could be 2 possible outcomes. What should I have said? Because 2 possible outcomes doesn't necessarily work with a dice, because a dice is still a simple event.
Yeah, just
Fixed number of outcomes.
let's say fixed number of outcomes. I don't know how to explain that. Simple event versus compound, like you're doing it once, right? You're not doing it twice. You don't have 2 children or 3 children. You're only doing 1 child. Okay, fixed number of I don't know. Anyway, whatever. Okay, all right, let's go to here. Do you see this little thing on the side over here? Probability can be expressed as a decimal number, as a fraction, as a percentage. Got it? Those are 3 different ways of expressing probability. I do not care which one you choose. So if you on number 4 came up with 20% and somebody else right next to you said 1/5, I don't care. That's the same thing. Okay? Unless it specifies, I don't care. I will accept any of those. All right, what's the lowest probability that you can get? 0%, right? 0% as a fraction is 0. 0 as a decimal is 0. Okay? What's the highest probability that you could get? 100%, right? 100 as a fraction could be like 3 over 3 or 1 over 1 or 100 over 100, right? Which is really just 1, right? What's 100% as a decimal? 1, right? Okay. They have another one on here that says a 50-50 chance. Means your probability is 50% as a fraction. 1/2 as a decimal. 0.5, right? I don't care which one you choose, but that is that. You cannot have a negative 30% chance of something happen. You cannot have a 120% chance of something happening. Okay, now, Cody Hubble. Do you guys remember who Cody Hubble is? Kyle Hubble's older brother?
yes.
I remember I taught him in stats, and this would have been like 4 years ago, okay? Like 5 years ago, maybe. 4? I don't remember. You took his senior year. He sat in the front row and he was like, wait a second, I've heard of 120%, like that being a number thrown out in math. Like that's a thing, okay? That would be like percent growth. So you guys have 14 kids in here. And if I say that your percent growth from this class to next year's class is 200% growth, that would mean next year's class has 28 in it, right? You've doubled if you are 200% growth. You can have percentages that are larger than 100%, but not for probability. Make sense? That's percent growth, not probability, okay? Probability is 0 to 100, numbers in between, no negatives, no above 100. Got it? So he was right. He's heard of numbers, percentages higher than 100. Great, but that was percent growth. Good? Okay. Things that have a 0% chance of happening is something that is impossible if it has 0. Okay? Something that is really close to 0 but not like 0 itself is something that's very unlikely to happen. Like we had 0.000003. That's not impossible. You could still get a 75-25 split for boys and girls, but not very often, right? Okay? So unlikely, certain, or 100% gonna happen versus likely, right? Like a 98% chance of something happened would maybe be likely. Whatever. Okay? Got it? Impossible versus 100% certain to happen. 0 and 1. Okay, let's do this. All right. All right, probability. The number of times something occurs over the total number of times it's repeated. Okay? So, let's say I flip a coin and I ended up getting 3 heads and 7 tails. Is that uncommon to get 3 and 7 split for flipping 10 coins? No, probably not, right? 3 and 7, that's okay. But if I say the probability of heads, what would my probability of getting heads in that scenario be?
Well, 50-50 should be.
Yep, that's a good, okay, theoretical. In theory, the theoretical probability of getting heads would be 50-50, so 0.5, okay? The experimental probability of getting heads in my case right here was 0.3, 30% chance, right? Okay, so there's a difference between theoretical and experimental. According to my experiment that I did here, which I just randomly made up those numbers, right? That's the probability that I got, okay? But it is the number of times it occurred over the total, right? That's how you find probability. We knew that, right? Maybe? Like that was not that bad? Okay, all right, real quick. This is something that is hard for me to explain, but this is like literally a standard that you guys are test over. It's something called the law of large numbers. Are you ready? Okay, here we go. All right, I'm going to explain over here. If I flip a coin 10 times, like I just said above, and I got a 3 and 7 split, right? Well, that's not uncommon, right? That's technically a 30% versus a 70% split, right? But what if I flipped that coin like 1,000 times? Would you be surprised if I flipped that coin 1,000 times and 300 of them came up heads and 700 of them came up tails? Would that be surprising? Why? Why is that the case? Yeah, it's something called the law of large numbers. The split should be 50-50, right? It should be a 50-50 split. So what the law of large numbers says, the more that I do the thing, whatever thing it is, right? The more children that I have or the more coins that I flip, the more those two things should end up getting toward what the theoretical probability is, right? In theory, it's a 50-50 split. So the more times I flip the coin, the closer those numbers should get to be a 50-50 split. Right here, it's a 30-70 split, right? But if I flipped it 1,000 times, it should be closer to a 50-50 split. Or 1,000,000 times, should be closer to a 50-50 split. Does that make sense? Okay? Like if I had 3 children and I had 3 girls and no boys, that wouldn't be like, oh my gosh, I can't believe that, right? Versus if I had 10 children and all of them were girls, you'd be like, holy crap, I cannot believe she never had a boy, right? Does that make sense? Like the more times it happens, the more repetition happens, the closer that should get to be a 50-50 split. Got it. Okay. So as a procedure is repeated again and again, the relative frequency of the probability tends to approach the actual probability. So the experimental probability approaches the theoretical probability, okay? That experimental probability will approach the theoretical probability. Got it? Do we see how this works? Okay. We'll get in with this page and then we'll stop. We have 4 problems left. And these go fast. Okay. I love some of the examples that they give here. This is great. Find the probability of dying when making a skydiving jump. Okay.
Sounds like
In a recent year, 3 million skydivers jumped and 21 of them resulted in death. Find the probability of dying. So we would note that as probability of dying is equal to 21 over 3 million.
5 zeros and a 7.
1, 2, 3, 4, 5 zeros and a 7. Cool. That's it as a decimal. This would technically be it as a fraction, except we would need to reduce. 21 and 3 could be 1 and 7, right? 7 over a million instead of 21 over 3 million. And if you write that as a percentage, it would be 3 zeros, 0.1, 2, 3 zeros, a 7 and a percent. I don't care which one you do. You're probably going to give me the decimal, whatever. Okay, that's your chances of dying when you skydive. That's still too big of a percentage for me. I think this is still too high of a number. It's like a way small, like not even 1%. But that's still too high for me. Mm-hmm. Yeah. Nope. All right. Yeah.
I would be screaming on the way down.
No.
I have fear of falling.
All right. Example 4. When 3 children are born, the sample space of genders is shown in example 1. Boy, boy, girl, boy, girl, etc. There are how many? 8. Do you remember why there's 8? 2 times 2 times 2. If boys and girls are equally likely, then those 8 simple events are equally likely to happen. I could have one of those things happening. Assuming that boys and girls are equally likely, find the probability of getting 3 children, all of the same gender, when 3 children are born. What does that mean?
They're all girls.
If they're all the same gender, that means I'm looking at either getting
Girl, girl. So 2 out of 8.
boy, 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 or girl, girl, girl.
Would you take
How
2
many
out of 8?
combinations is that? 2 out of 8, right? 1/4. Or 0.25, or 25%. I have a 25% chance of getting all 3 babies be the same gender. Okay.
Interesting.
Interesting. Yep, yep, yep.
Well, that would be annoying.
What?
All the same gender.
You think so?
I need at least one.
Girl, girl.
I need
Girl
one
would be
different.
all annoying.
You think so?
Like, Tate.
Tate, you don't get to choose.
No, I need though.
Oh, okay.
I mean, isn't the
Well,
guy?
you could just keep having kids. Law of large numbers said they should even out at some point, right? What?
Isn't the guy responsible for the gender anyway?
Yes, it is.
So if you're unhappy, it's
My
your fault.
sister-in-law has the same, like she has 6 kids. She had the same situation happen as like I did for the first 4 children, which is kind of funny because my husband is the same pattern, and his mom was the same pattern. My family was the same pattern. Okay, we had boy, no, wrong. We had girl, boy, and then whoever had a 4th one had a girl. That was the same pattern every time. Okay. Now, if you look at the first 2, if you only look at the first 2, we're 100% girl, right? If you look at the first 3, you're 2/3 girl, right? But if you look at the first 4, you're 75% girl, right? So after 4 children, I am 75% girl and 25% boy. Yeah? Okay? And my sister-in-law, if she would have stopped there, she would have been 75% girl and 25% boy. But she had 2 more children, and guess what they were? They were both boys, which evened out, and now she's 50-50. Law of large numbers, right? I'm not saying it works for everybody, but like if you keep having 20 children, it should eventually
Like our father.
even out. No.
Oh,
No.
also, I don't know whether to say congratulations to you.
Oh yeah.
on Facebook. Yeah, I'm so
we're having a
happy.
little boy. Not me.
They are
My
not you,
sister.
But just got just as
Yeah, very exciting. Hello. What's up?
Before, or if you get it like to a dead spot when you're done lecturing,
Yeah.
I want to talk to the seniors who are going to nationals before
Oh,
you guys.
Give
wanna
us,
talk
like,
to him
2
now?
more problems.
we have 2 more problems and then we're ready.
Is Aiden not? Oh, there. I want to talk to you first. 'Cause I have you're missing your mentee thing.
Do you want me to send him down
Yeah.
to your room?
That's fine.
Sure. Okay, that'll work.
Thank you.
Okay, perfect. All right, 2 left. Example 6, texting and driving. In a study of U.S. high school drivers, it was found that I can't breathe. It was found that this many texted while driving.
That's a lot.
Actually,
Text.
and I saw a guy who was like texting on the interstate.
No.
I don't text. I did like the little Siri, like, hey Siri, text dad.
But like the
or
interstate's
oral
dangerous.
call.
Then he started to like shift into the like the
I would never text.
All right, so my yes texters are 3,785. 4720 said no texting.
How many of them are lying?
My no texters are 4720, and that's out of the past 30 days, right?
How many
Okay.
are lying?
I don't know. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving.
So yes.
We want to know the yesers.
So 3785
37,
out of
85 plus
Out of, yeah, not out of the 4720, out of these 2 added together.
8505.
8505. Okay.
no divide, Josie.
And we got to divide. 3785.
85 divided by 85.
A little less than half.
0.445.
0.445 or 44.5%. Whichever you want to do. I don't care. Okay? Make sense? All right. Thanksgiving Day. I love this example because I get somebody every year. A, B. Okay, here we go. If a year is selected at random, find the probability that Thanksgiving Day in the United States will be on a Wednesday or that Thanksgiving Day will be on a
It's always on a Thursday.
Thursday. I always get somebody to say 1 out of 7, right? And 1 out of 7.
No, it's always the third Thursday, isn't it?
It's always the
Third
third Thursday,
Thursday?
last Thursday.
The third Thursday.
Which one's 100%?
On a Thursday.
100% here. What about A?
0%.
0%. Some people don't know that Thanksgiving's on a Thursday. Did you know that?
They play football.
Yeah.
Because Black Friday.
Yeah, Black Friday is the day after Thursday, right? Okay, there you go. All right, you should, on your homework assignment, you should be able to do, I don't know.
None of them. Don't do any of it.
Yeah, you should be able to do the first page,
Okay,
Procrastinate.
all the way through,
Procrastinate.
5 through 20, the first page. All right, goodbye, people.